Hello everyone. In this video, we will try to understand where we should use heap and what are its identification elements, right? So I have written down some points. Let's go over them one by one. So first one is sorting, right? Now, if let's suppose the generic problem statement is given to you, then one thing you would able to understand that the problem could be easily or can be solved using sorting. The problem can be solved using sorting, right? So you will see that okay, um, let's say the problem is like kth largest element, right? Very standard problem for heap. So the kth largest element, and you can just simply seeing the problem, you can know that okay, if I'll sort the integer array which is given to us, which is the input, then I'll just find the kth index, and then that's how I will be getting the kth largest element, right? So in that way you would probably see that sorting could be the one approach where the problem can be solved. So you will be seeing this sorting as one of its identification of heap problem, right? Okay, so what next? The next one is like you will see or you will able to identify some keywords, which is like top or maximal, right? Largest, and out of other than that there could be smallest, right? Minimum and maximum. So basically what I mean by that is the problem would be asking to maximizing the stuff, or it could also ask about minimizing the stuff, right? I'm just writing it down. So it could be asking about maximizing the stuff and minimizing the stuff. So just one point I would like to clarify over here is don't confuse it with DP, right? Because standard DP problems are also asking about maximization and minimization, also recursion. So those, don't confuse those with DP or recursive approaches. You first need to think greedily, right? Let's suppose you got any problem, right? Then first think it using greedy approach, right? Once you got some test cases, right, try to identify the test cases. If you get the test cases which are not able to solved using greedy approach, then try out the DP approach, right? Because that might be solved using DP approach, but that not could be the most optimal way, right? He could solve the same problem in more optimized manner. So that's why I'm saying like the problem could be asking the minimization and maximization stuff. Similar could be there, but don't just directly jump into the DP part, right? If you have the test cases that our greedy approach is not able to solve, then go to the DP section. If not, then try out first with greedy approach, right? So this is the second identification element which we should consider while thinking in a direction of heap. The second or third one is the k, right? You will basically in the problem statement itself you will be given kth something, kth largest element, kth smallest, k closest point to the origin, and so on. So the k factor would be given to us, right? This is like very great to understand this, though I'm not 100% sure that if k is given then we should definitely we should use heap. But yeah, probably in more than 80% of scenarios, if k factor is given or k term is given, then we should use heap, right? And the fourth one is like the basic log n to log k. Now what do I mean by that is, let's understand with the example. So before that, let's try to understand the time complexity of sorting. So sorting, if you will use standard collection sort, then it will solve it in the time complexity of n log n, right? And let's suppose we have an array of n elements, right? Let's say 1, 2, and so on, right? So we have n elements. Now we have an data structure heap or priority queue in C++, whatever you can call them, right? Internally, it's, we all know it's CBT or complete binary tree, right? So internally, what initially what approach you would just generic think is that you will just try to store all the elements of array into the heap data structure, right? So the insertion cost is log n, and you are doing that for n elements. So the time complexity of just storing all the elements of the array into the heap is n log n, right? So anyhow, if you will try to insert all the elements into the priority queue, it will move to n log n. And our sorting also does some same time complexity in n log n, right? So that doesn't help us out while solving the problem, because anyhow, as I said in the first point, that sorting is one of the technique which could solve our problem, which would be clearly seen in the problem statement as well. But the time complexity is again same, right? So we need to do something better. So what the third point state is, just 1 second, I'll just try to remove everything. So okay, now I'll again also give one more example. So we know all that what is complete binary, right? All the levels will be completely filled except possibly the last one. So this is what complete binary tree is, right? Now let's suppose we have elements over here, right? And like we all know the depth is log of n, right? If n is all of the elements in the array, this is an FE trying to convert that into heap, right? So without heapify, the time complexity goes to n log n, right? That's we all know. And the depth of the tree also becomes log n, right? So we need to optimize it. Like we need to reduce the depth so the time complexity reduced by some amount, right? So what we do generally is to I'm just talking about identification, right? So we need to reduce this log n. So now how we can do is we can just create a tree by depth of k only, right? So if we will create a depth of k, a binary tree of the depth of k, then our time complexity will approximately reach to n log k, right? In that we will not store all the elements, not store all the elements, right? And the idea is basically that if the size of our heap, right, if the size of our heap goes above k, then you just simply pop it, right? For now, just try to just consume this part what I'm saying. In future videos you will able to understand what I'm saying, right? So this is the third identification element. Now I'm again repeating what I mean by that is that if you will simply insert all the elements into a priority queue or the heap data structure, then it will cost us the time complexity of n log n, right? And sorting is also doing that part in n log n. So anyhow, our time complexity would be same, and the online judge would tell us to optimize the problem. So what could we do? We just try to reduce the depth of the binary tree from n or log n to k or log k, right? This is what we trying to achieve, right? After that, our time complexity will reduce for the insertion from n log k, right? And how did we achieve that? So we will just try to maintain this depth by log k, and if let's suppose we get the size of our container is more than k, then we simply pop the top element, right, which we don't want. So yeah, these are all some points which I would like to give you a small about heap and where we should try to think in a heap way. So that's all for this video. I hope you get a small value from this video, and thank you so much for watching.